Hello everyone, this is James Shore with another test-driven JavaScript video. I'm recording this on July 11th, 2012, picking up where we left off in the last video where we were working on continuous integration. And we have the build working on Windows, which is awesome. I love it. And now what we need to do is the integration part. Now, when we left off, I'd created an integration branch. And let's show that. Git K is a visualizer for Git that just shows you all the branches and so forth. Well, it will show you all the branches if you have the all option, which is what I used. So you can see the integration branch. What we need to do, though, is we need to actually automate. We need to automate the integration. And I'm going to cheat. I love cheating because it sets aside all the crap that everybody else wants to do and, just makes everything easier by doing stuff that everybody thinks is stupid. So I'm going to cheat. Let's make an integration target for Jake. We're going to want integration to work to run against the build. We'll start out making that run against default for now. So let's see. Build, test, build and test is what that will be. And our integration logic goes here. Okay. Let's make sure that works. Yep. And we can also confirm that we have it here. Good. And we can actually do that there. Great. Yeah. It builds everything and then gives us our integration logic. Perfect. Okay, so now for the cheating. The terrible cheating. Normally what you would do at this point is install a continuous integration server. As I said, most of those get it wrong because continuous integration, you should never, ever have a broken build. It should be physically impossible to have a broken build. Here's how we're going to automate that. We are going to use the slave known as the person at the computer. Step one, make sure Git status is clean. Step two, build on the integration box. Step three, okay, and the way we build on the integration box is walk over to integration box. We git pull. And then we Jake. Okay, once we've done that, three, we want to check out the integration branch. The way we do that is git checkout integration. And then we need to merge. And I'm going to use a variant of merging called the no fast forward merge, because what that will do is that will preserve the integration branch as its own thing. Typically in Git, if you merge to a branch, but you haven't made any changes to your branch, or you haven't made any changes to that branch since the thing you're merging, it will just sort of move. It's really hard to explain without visualizing it. So what I'm going to do is I'm going to tell it to not do a fast forward merge so that the integration branch, when you visualize it, shows that the master branch has been merged into it. So we're going to switch to the integration branch. We're going to merge the master branch with the no fast forward option and the log option. And what that will do is that will bring in all the commit logs from the previous commits. And then we need to switch back to master. Now, again, I'm not a Git expert. I hope I got that right. I think that's how it works, but I'm not 100% sure. Let's Let's try it. So what we're going to do is we're going to commit. We're going to say that we have set up continuous integration script. What we didn't say is that you have to do it yourself. Okay, so now get status is clean. So let's integrate. So get status is clean. Walk over to integration box. Git pull. What's next? Jake. That worked. Then we say git checkout integration. Now I'm going to show you the visualization for this. What you can see is that there's our setup continuous integration script check-in that we just did, but here we are. This is our current location in the tree, and there's our integration branch. Now, and the git checkout moved us from master to integration. Now we're going to merge. And if I reload this, you can see that now our integration branch and our master branch are separate, and our master shows that we've merged, or our integration branch check-in shows that we've merged the master into integration, and here is the check-in we merged. Now if I hadn't done the no fast forward, it would have just moved the integration branch up without making a new commit, so we wouldn't get this branching structure. We're almost done. Now we need to switch back to the master branch. You can see right here we're on the integration branch. We're going to switch back to the master branch, and there we go. I do want to make a correction here. Console.log. If Jake fails, start over. Stop. Try again. There. Now commit and say modified integration script to prevent build or integration build branch build failures. It's really that easy. It is now impossible. It is impossible for our integration branch to ever be broken. It's just that simple. How cool is that? And I can't believe that people who make continuous integration tools forget this. This core idea that it should be impossible for the integrated branch to fail. Now, there's lots of ways of doing this. If you're using something like Subversion, where you don't have the easy branches, then what you can use is a rubber chicken. I'm not kidding. We'll look up continuous integration rubber chicken right here. Yeah, you can use a rubber chicken or other stuffed animal to signal to people that the build is not in a state to check in. And then what you do is if the build fails, you roll it back. And again, always builds and pass tests. That's the important point. There we have it. Let's go take a second look at git k. Now that we've checked in another file, you can see how our master branch and our integration branch are moving along on separate paths here. Let's integrate that. Normally we won't integrate quite so frequently. Jake integrate. Git status. Oop, we're missing a semicolon. That's interesting. The build didn't fail. Let's make a note of that. We need the build to fail when Jake file fails. Oh, and I know what I did wrong. That's good. I'm glad that came up. So let's go back to WebStorm, make a note. We need to make build fail when lint fails. Okay, so we need to fix this. What exactly is failing? Jake. Line 26. Missing semicolon. Of course. There, now we're good. Okay, but before I go much further, I do want to fix the issue with the build not failing. So let's go ahead and take out, just for example, let's take out, yeah, so we've got it failing. We've got lint failing, but the build isn't failing. That's because we should be saying lint validate file list or fail. That's a bit tricky. We could also take it into a variable and, you know, talk about that, but I think this will be okay. There we go. Lint failed. That's what we want. Okay, so let's get this back in. I'm not sure. Expected an assignment or a function call. There's something about the syntax that I'm not getting here. So I'll just do it this way. There, finally. We're building clean. Let's check that in. Build fails if lint fails. And let's go ahead and integrate. So we're good here. Git status is clean. Walk over to the integration box. Git pull. Build known good. Git checkout integration. Oops. You can see how we could automate part of this if we wanted to, but this is an easy way of getting started. So we need to git merge master, no fast forward, and do the logs, and then back to master. And let's take a look at git k. Great. So now we can see how every time we've got a known good build, or we're periodically bringing our local check-ins into the known good build, which is the integration build. That's all the time we have for this episode. That's it for continuous integration, I think. Next time we'll pick up with our first set of tests, I think. Thanks for watching, everybody. I will catch you next time.